Okay, start.
Greetings. You are once again welcome to my channel, Dear Flamingo LL Lawson. But before we begin today's lesson, let's take these quick reminders. Please kindly subscribe if you have not still done that, and you can drop your comments. You can even propose certain videos or video lessons that you want us to do for you. That is also fine. And also, when you go to my channel, visit the playlist. So within the playlist, we have these topics arranged according to the subjects. So when you take general mathematics, we have series of math topics. When you take chemistry, we have series of chemistry topics. So please always visit the playlist, right? Good. We've packaged them nicely. Thank you. We will be looking at a physics topic today: density and relative density. Density and relative density. Now we will first start with density. Now what is density? Defined as the mass per unit volume of a substance. So mathematically, that is a mass over volume. So define density. If you define density in this way, it is still correct. We are doing mathematics, not English. So it's accepted. Good. Math is science. Science is math, right? The SI unit for density is kilogram per cubic meter. Good. Now we have some conversions we'll be looking at. 1000 grams equals 1 kilogram. 1 gram per cm cube equals 1000 kilogram per cubic meter. Now 1 million centimeter cube equals 1 meter cube. So these are the parameters we'll be using. Now let's look at this sample question. A block of mass 2 grams has a volume of 15 centimeter cube. Determine the density of the block in gram per cm cube and in kilogram per cubic meter. So let's see. So let's look at the solution to this question. A block of mass, so there's a mass, 2 grams, has a volume of 15 centimeter cube. Volume 15 centimeter cube. Determine the density of the block in gram per cm cube. So I'm supposed to determine the density in gram per cm cube, and also determine another one again, the same density in kilogram per cubic meter. This is standard, that is not standard. Good. So density equals question mark. Good. So density equals mass over volume. Now what is my mass? My mass is 2 grams and my volume is 15 centimeter cube. Now when you punch 2 over 15, what are you going to get? 2 over 15, 0.133, right? Good. So 0.133. Now this is gram. This is, let me put it here, 0.133. This is the gram. Now there is a partition sign, and there is a cm cube. Good. So I have calculated and I've left my answer in gram per cm cube. Now this thing you see is the same as this. When you move this partition sign, you bring a minus here, right? Good. So the next one, so easy. Calculate and leave your answer in this way. We are going to use a parameter that's very short, but 1 gram per cm cube. Please don't change the parameter, because 1000 kilogram per cubic meter. You say this is 1000 grams equals 1 kilogram. The fact that you see 1000 grams or 1 kilogram here does not mean that this should also be 1000 grams per cm cube. Once you see this volume term, it means the cm cube is under this g. Certain cancellations have gone on. That is how come we had here 1. So the fact that we see 1000 grams does not mean this should also be 1000. Please know. So let's go. Let's have it convert. Then, if this equals this, so how do we use this parameter? If you want to end up in kilogram per cubic meter, let this part of the parameter be on the right. If you want to end up in gram per cm cube, circumvent it so that this part will be on the right, then you end there. That is it. So let's go. Then 0.133 gram per cm cube will give me 0.133 gram per cm cube. This will come under it every day because of this approach I'm using. Times what? 1000 kilogram per cubic meter. So this and this will go over, as you can see. Now 0.133 times 1000. That's 133.33 kilogram per cubic meter. So that is what you are going to get for the density, right? So it's true. Calculate and leave your answer in this form. I've done that. Calculate and leave the other answer also in this form. I've also done that. Now we can also have some alternative to this. What if I don't want to use the parameter? Then I have to go a long way. Okay, let's look at that. Good. So that is it. So it's very short, very easy to use this approach. Always remember the parameter. That's very easy. Now what if you want to change them term by term? Change a gram, change volume. What is the essence of this? It looks very lengthy, that is very true. But it helps. At least it will help you to even know how to convert certain things. There are some questions that you need to maintain one, maybe this can be in kilogram. You just need to convert this volume. So you see, you still have to learn this method. So let's look at the alternative. So the mass here is 2 grams. But 1000 grams equals 1 kilogram. Then 2 grams will give me this. You see, always. Remember what I told you? So this is what I'm going to get. Now, 2 over 1000 will give you 2 times 10 to the power minus 3 kilogram. So please, when you are working out and you punch a calculator and you happen to get something in the standard form, it's okay. Don't try to convert it to the common form. You can still use it, right? Good. So this is the same as you getting 0.002 kilogram. 1, 2, 3. Yeah. So it's the same thing, as you can see. Now let's look at the volume. The volume happens to be 15 centimeter cube. So I am doing the alternative for the II, the second one. The volume happens to be 15 centimeter cube. But we know that 1 million centimeter cube is equal to 1 meter cube. Then, what will 15 centimeter give me? So before you do, make sure on the left, the units are the same on the left, as you can see. You see? Before you convert. Because you can't be doing the conversion and the meter cube is here, whilst the cm cube is here. No, it should be the same, right? Then you go this way. Then 15 will give me what? As if there's more divides, so to speak. Good, we're going to get this by 1 meter cube. So see, it goes off. You see, I'll end up getting a meter cube. Or something, a gram goes off, I end up getting a kilogram. That's what you see. So when you code that parameter, make sure what you're going to change is of the same unit on one side, maybe the left, right? Good. Now, what are you going to get for this? When you divide this by this, what are you going to get? So that's 1.5 times 10 to the power minus 5 meter cube, what you see. Or it's 0.00015 meter what? Cube. 1, 2, 3, 4, 5. Yeah, that's right. So I have to calculate my density. So density equals mass over what? Volume. Density. Now what is my mass? 2 times 10 to the power minus 3. Please, anytime you are working in standard forms, try and put the standard forms in brackets on the calculator. It can jam up. So you put this in brackets on the calculator before you go divide the denominator also in brackets. Good. You have to understand how the calculator works. It's very important. So when you put this together, you get this answer. The same answer you see there. Good. Good. So this one looks lengthy, but it's very good. Because when it happens that you just have to change one parameter, that is what you have to do. If you have to change just this, you know how to convert. If you have to convert just 15, you also know how to convert here. This is also very easy, right? Doesn't throw more light on conversion. So any of the two methods you can employ. Okay. We are still on density, relative density. So that is designed to help non-science students, right? Those who do integrated science or those who do physics as a core subject, right? Good. So these are selected inter-science questions from the past question. So let's look at that. A body of mass 2 kg flows on water. If the density is this, determine the volume of the body. Now, there is a mass of the body. Solution to the problem. There is a mass It is in standard. You don't need to change to grams. The density of water. The value was given as 1000 kilogram per cubic meter. I told you, right? That is standard. So determine the volume. So anytime you are given a question like this, the best thing for you to do is to list the parameters out. Now you quote a befitting formula. Then the formula itself will tell you how to go about it. Mass over volume. So there is a formula. Density is defined as mass over volume. Now what is the mass? The mass, I'm getting 2 kilogram. Now the density is 1000. Let me leave the units out. And the volume, we don't know. So when you cross multiply, you'll be getting 1000 V equals 2. That is if your change of subject is not good. That is also how best you can do it. 1000 V equals 2 over 1000 over 1000. Now, when you divide this by this, you get 2 times 10 to the power minus 3. And what will be the units? Now look at this. We have kilogram here, and we have kilogram per cubic meter. So if this value should cross out, this is kg here, it will be left with a meter cube. Now the meter cube, that's m raised to the power minus 3 here, going up will become positive. So that is it. Anytime you have your masses in kilogram, your densities in kilogram per cubic meter, you end up getting a volume term m raised to the power 3. Good. Anytime you have your mass in grams and you have your density in gram per cm cube, you end up getting your volume term cm cube. Good. That is it.